Hi everybody, this is day 2 of our unit on Light and Spectra. Scratch on my nose, getting a lot better, no more Band-Aid. Glad to report that. And we are talking about light, and the reason light is important in astronomy is because that's almost the only information we can get from something is its light. So we need to learn, as astronomers, we need to learn how to capture that light and how to analyze it and figure out what kind of data it gives us. So the first thing we're doing, I've got you reading a document about what is light and what are some of the different kinds of light. There's the light that we can see, which is red, orange, yellow, green, blue, and purple, right? And then there's like longer wavelength light that you're reading about, like infrared, microwaves, radio waves. Those are longer wavelength that we can't see with our eyes, but they're still electromagnetic radiation. They're still light. And then there's shorter wavelengths than we can see, like ultraviolet, which you've heard of, X-rays and gamma rays. Those are really short wavelengths. So we're going to learn about all these different types of light and why they're important in astronomy. So today you'll be finishing up that assignment that I gave you on Google Classroom, either option A or option B. That's the goal, is to finish it up and watch this video. So I'm just going to show you a couple more gas tubes and what the spectra look like when we break up the light. So this is a tube filled with, see, can you read that? Right about there, it's neon. So I'm going to put the neon in this one, the one that says danger. And then this tube says, you can read it, it says nitrogen. I'm going to put that in here. So these tubes are filled with gas. This one's filled with neon gas, this one's filled with nitrogen gas. And these boxes run electricity through them. And when the gas gets that electricity through it, it gets energized or excited, and then it has to release that energy. And when it does, depending on what element it is, neon, nitrogen, hydrogen, helium, when it releases that energy, it releases it at certain wavelengths or colors. And then I showed you yesterday, we look at it with one of these handheld spectrographs, and it actually breaks up the light. So I'm going to do that again. So here's the neon. Where is it? There we go. Nice neon light. And here's the nitrogen. Let me go turn off the light so we can see this a little bit. Wow, those are just really bright. So let me cover this one up so we can just see the neon first. That doesn't help. That neon just looks white, doesn't it? It's actually orange. So the neon light's orange to our eyes, but if you look at it with the handheld spectrograph, this neon, it looks like this, and hopefully I'm showing you a spectrum of neon right now. It breaks up all the individual colors, and you'll see them. Now our eyes just see it as orange. In fact, I think I should turn the light back on. That's so saturated because it's so bright. I think we're better off seeing the orange if I turn the light on. Now nitrogen looks kind of pinkish or purplish, but if you look at it with the handheld spectrograph, you can see it broken up into its individual colors. And I'll show you that spectrum now on the screen. You can see how nitrogen and neon actually look quite a bit different to our eyes. They also look different when you break them up with a spectrograph. So that's some of the work that we'll be doing. Okay. Now, if you're ever dealing with these, the neon ones get really hot. So do the nitrogen ones, so I'm not going to touch those. Okay, so there you go. There's a couple more spectra. Today your goal is to finish the assignment that you started on Monday, and then we'll meet all together in class on Wednesday in WebEx. Okay, great.